time, which would be 10 minutes before the lesson ends. The lesson is 45 minutes, so they are at 12:35. I will stop the lesson and we'll do question and answer time. So I can go back to slides if you have any questions, or I can re-explain something if you want me to. So welcome to Natural Science Grade 8. We're on week 3 for this lesson, and it's lesson number 1 for today. My name is Arifa Hafaji, and I'd like to welcome you all. Okay. So at the end of the lesson, what I'd like you to know is basically what we continued from last week. We discussed density and the states of matter. I'd like to continue discussing that because we stopped at gases last week. And I'd like to explain to you how oil floats in water. And then I also want, in earlier lessons, I taught you the formula for density and how you should calculate density. But today I actually want you to calculate density. So you're going to use the formula. So what you would need for this lesson today, and what will actually help you, is if you can actually get some paper and some pen, so you do the calculations. And also if you don't understand anything, then you can just jot down whatever you don't understand. And then before the lesson ends, then we'll do a question and answer to discuss or summarize things that you'd like me to work on or help you develop the skills. So quick recap on what we did last week, Friday. So we said density of a material is a measure of its relative heaviness. Now basically what that means is density is measuring how heavy something is. So we use it in fancy terms where we say density of a material is a measure of its relative heaviness. And that basically means is how heavy a substance or a material is. Right, so the denser materials, it has a greater mass in relation to their size, and that is why they feel heavy. So that means that the mass is basically how much space a substance takes up. So the greater the mass, it will probably be the heavier the density of the substance. So the density of a material basically depends on two things. It depends on mass over here, and it depends on its size. So when we are going to explain what I meant by it depends on its mass, the individual particles of that material is basically the mass of that material. So we say the larger the mass, then the denser the material it is. And then we're going to go on to saying why it depends on its size. Now the size of the spaces between the particles. So we're talking about the spaces between the particles. And it says that the larger the spaces, the less dense the material would be. Okay, so let me explain that a little bit again for you. So we said mass, density depends on mass. So it is the individual particles of the material. So the larger the mass, the more dense the material would be. And then when we talk about the size of the spaces between the particles, the larger the spaces, the less dense it would be. So while I explain that to you, I want you to think of the brick and the loaf of bread scenario that we used last week, where I explained how the loaf of bread and the brick were the same size, but how come one was heavier than the other? So this would be the space of the particles between the bread. It was greater, it was less dense, which made the bread lighter. So now we're going to calculate density. Now the formula to calculate density, I want you to write this down. So density is equal to mass divided by volume. And then if you use it in simple forms, excuse my writing because I'm still learning how to write on using the ink and the keypad. So it's going to be D is equal to mass divided by volume. So D is density, M is mass, and V is volume. So, and then remember that when you're going to write your answer, you must also always write it with the units of measurement. So if you're using grams to calculate density, so your unit of measurement would be, say, gram. And then you say if you're using milliliters per ml. So that is your unit of measurement that you're going to use. Okay. So we're going to continue with density and the states of matter. Oh, sorry. Gases are not very dense at all because of the large spaces between the particles. So we know that gases, it is not very dense because of the large spaces between the particles. So this means that they contain a small number of particles in a large volume. So if we had a large volume, if we had to put the gas particles in a large volume, there'd be basically a small number of particles in it. So this is why we say that gas can be compressed. Their particles can be squeezed closely together to fit into a small volume. So we can take the same gas that is in a large volume and put it into a container or that is of a smaller volume, and the same amount of particles can be compressed together and it would fit together. Okay, so we're going to just recap of how the particles are put together in a solid. Can you see that the particles are very, very close to each other? They're right next to each other and they're in a fixed position and they vibrate next to each other. And the spaces between these particles here are absolutely small. And if you compare the spaces between the particles to the liquid next to it, so the particles in the liquid, they're not in a fixed position. They're free to move, and the spaces between them are much bigger than the one in the solid. Now, if you look at the picture of the gas, where the particles are, you can see there's very few gas particles, but the spaces between them is quite significant. There's quite a big space between them. So we say the energy in the particles. So in a solid, there's least amount of energy. Now, because it has, even though it has the least amount of energy, so we say the forces between them are great. So each particle here is attracting each other to keep it together. So we say it has a strong force. So we say the energy in a liquid, it has energy, and the energy is between least and it is between both. So it has an average amount of energy in the liquid, and it also has strong forces between them because the particles in the liquid are closer together than they are in a gas. Now, even though they are closer together, they are not as close as the particles in a solid. So now, gases has the most amount of energy because there's lots of spaces in between the particles, and this means that they're free to move, so they can move around very, very fast. And there's basically no force, attractive force between the particles because they are very far apart. So I'm going to show you another diagram here that also explains. Now, in a solid, we look at the particles here. It's compact, it's closed, and it's definite, and it's fixed. So in a liquid, they're free to move around, and in a gas, they are far apart. So basically what I've been telling you in this slide, and I showed you one in by discussing it in the words, then I showed it to you in a picture, and then I showed you in another picture that shows it. So you could have a more foundational understanding of how the particles are in a solid, in a liquid, and in a gas. And it also, if you relate it to density, why certain substances are more dense than others, just because the way their particles are comprised next to each other. Okay, so basically you have learned that the density of a material depends on how tightly packed the particles inside the material are. So we know that the density of a material depends on how tightly packed the particles inside the material are. And the more tightly packed they are, so it is the more tightly packed, it means that it is more dense. So you can write this down. The key words that you can write: density depends on the material. Density is the material depends on how tightly packed the particles inside the material are, and the more tightly packed they are, the more dense the substance is, or the material is. So if we're going to look at this diagram here, so the following diagram, it represents the container, a container. And this container has basically a small amount of gas in it. And you can see it's a small container, so the gas particles are close to each other. Now, imagine that you had to take this container and you had to put it into a large container. So what I want you to do now is I want you to draw a small container. You can draw a cylinder. So when you draw basically a cylinder, you basically draw two parallel lines on the side, and you draw a curved line at the bottom, and you draw a little circle at the top. Excuse my drawing, but that's basically how you draw a cylinder. And then you're going to draw the particles here. So I'm doing it so it gives you time to do it as well. So I drew 10, then 11, 12, 13. So now I drew these particles in a small cylinder. Now, how do you think the particles will be arranged in a bigger cylinder when I put it here in the larger cylinder? So let's see, you draw it, and then I'll give you, say, about 20 seconds, and then I'll show you how it is arranged over here. Okay, so this basically, we're going to take all this gas and we're going to arrange it into a larger cylinder. So that means it's going to be basically spread out. Okay, so excuse that one. So it's 9, 10, 11, 12, and we can put somewhere randomly 13. So now, can you see how these particles are now spread out, and there's a lot more spaces in between that. And this basically makes the particles in this cylinder less dense. And the particles in the smaller one here are basically more dense as compared to the particles in the bigger cylinder. So we're going to, I'm going to explain it to you again here. The gas will expand to fill whatever spaces it is in. So remember that we said one of the properties of a gas is free, and it takes up space, and it takes up the space of a cylinder or a container or wherever, or for example a balloon. If you fill a gas in a balloon, it's going to take up the space of the container you put it in. And the same number of gas particles that you have filled in a small container is now being filled in a big container. So you notice that the number of gas particles, I didn't add extra. It's the same number of gas particles that I moved to a bigger container. Now, if we take a certain amount of gas from one container and put it into another container, then the gas expands to fill the larger container. And the same mass of gas is now has a larger volume and it has a lower density. Now, because the volume here of the container on your right-hand side is larger, the density is lower. And if the density here is higher, it has a higher density in the smaller container, and here, because the volume is smaller and the gas particles in the larger container, the volume is much bigger, so it has a greater density. Right, so solids and liquids cannot behave in the same way. They have different densities which will remain more or less constant no matter where the container you have placed it. Now, this is because the particles are relatively close together with stronger forces between them. So now basically what I said here is that in solids and liquids, it's not like how it is in a gas. Now, in the solids of liquids, the particles are relatively together and the forces between them are stronger. But now I'm going to put a thought in your mind. You're going to say, but what will happen if you had to heat them? If you had to heat the solid and the liquid, what would happen to the particles? How will this heating affect the packaging of the particles and the density? Now, this topic here, I'm going to discuss tomorrow, where we're going to do expansion and contraction of materials, where we apply heat to it. Okay. I think there's a little technical glitch, so we're back to where we are. Okay. So now, density is super important because it relates to whether things rise or whether they sink. And the less dense materials tend to rise above the more dense materials. So I'm going to just change the color of my ink because the yellow won't show so much on my background here. So we say less dense materials, they rise they rise above more dense materials, especially in liquids and in gases. So we say less dense materials, it rises above more dense materials. So this basically means that the less dense materials can float above more denser materials, like I'll show you an example just now, and especially in liquids and in gases. But in the meantime, I want you to think of what material can basically float above water. What liquid can float above water? Okay, so understanding density has major implications of the motion of materials and gases, and the atmosphere, gases in the atmosphere, and the objects floating in the water. So the reason why we study density is because it has an implication on the motions of the materials, whether something rises, whether something sinks, or whether something can float on water. Okay. So now I'm trying to move to the next slide. Okay, so density is a reason some objects sink and other objects float. And this is the reason that some clouds are high in the sky and some are low in the sky. So when we say why some clouds are high in the sky, it's because it has less water vapor in them. And then the ones that are lower down in the sky, it has more water vapor in it, so it condenses. And then when there's more water in it, then it's more likely a chance for it to rain. So have you ever noticed that oil floats in water? Remember earlier on I asked you to think of a liquid that can float in water. So let's see why oil floats in water. So if you look at my image here, you can see that the oil is floating in the water. So when you mix oil and water, as in the and also if you mixed salad dressings. So I didn't put the picture of the salad dressing, I just put the picture of the oil and the water. But I also want you to know that salad dressings also, the two, one floats above the other. Now the two materials will eventually separate because they do not mix well, because they are immiscible. That means that they separate. Now, when they separate, the oil will always float on top. And the two separate layers of water and oil are referred to the phases. So you get the oil phase and the water phase. So if you look at the picture, so on top you have the oil phase where the oil is floating on top, and you have the water phase at the bottom, and you can see it's not mixing. So even if you have to stir this mixture, after a while the oil will still settle on top. It will go on top, and we're going to find out why. So the oil floats in the water for basically two reasons. So in this diagram here on the scale, we have water on the one side and then we have the oil on the other side. The cup of oil has less mass than a cup of water. So the oil is less dense than the water. So I want you to remember that a cup of oil has less mass than a cup of water. And we say, you won't believe it, but oil is less dense than water. So I would have thought that oil is more dense, but it's actually less dense. And this, because this is the particles in the oil are not close together like it is in the water. And this makes the oil float on the water, like how a cork or air-filled rubber ducks float on the surface of the water. Now, the water molecules, they basically attract each other, and the oil molecules stick to each other. So the reason why the water is more dense is because the water molecules, it attracts each other. So remember this, that why water is more dense is because the water molecules, it attracts each other. Oh, sorry. And then we have the oil molecules. The oil molecules basically stick together. Okay, so the oil molecules are sticking together. That's why it feels oily. Like if you had to touch water, you won't really feel a slime on your hands. But if you had to touch oil, it will be slimy, and this is because the molecules are sticking next to each other. This causes oil and and water to form two separate layers. Okay, so the water molecules are closely packed and they sink to the bottom, and this leaves the oil sitting at the top. So because the water molecules attract each other, they are closely packed and then they sink to the bottom. And then the oil sits on the top of the water. So oil does not dissolve in water. The oil molecules, they cluster together to float on the top. So cluster together means that they stick together. If a large amount of oil is poured on water, the oil will spread out and form a layer of surface on the oil. Now, you can apply this to the oil spills in the oceans, that when we hear that the oil has spilled in lakes and it covers a huge area. Now, this is very poisonous, and many fishes and birds and plants, they tend to die because the oil is preventing air from going into the water, and the fishes, they cannot breathe. And then sometimes the oil gets onto the bird's wings and it prevents them from flying. And when the oil spills, it's very expensive to clean up. And this is why oil pollution has an extremely negative impact on the environment, because it basically kills all animals, birds, plants, and fish life, because the oil prevents the plant or the fish or the bird or the animal from breathing, because it causes a layer over it. Now, if we had to compare the densities of sand, flour, and water, so I want you to do an experiment, and this is where you're going to use your paper and your pen. So you're going to do a practical activity. Now, this practical activity is called a doing activity. So when we say practical activity, we mean a doing activity. So we're going to compare the densities of a solid, a liquid, and a gas. Now, to compare this density is actually quite difficult to compare it if it was the three states had the same material, because the materials would have three different temperatures. So it's difficult to compare solid, liquid, and gas in a of the same material, because it has different temperatures. So for this reason, we're only going to compare sand, water, and air. So I want you to take this down. So you're going to compare sand, water, and air. So you're going to basically conduct a hypothesis. Now, a hypothesis means that what you're going to predict. So which material has the highest density? So your prediction would be, say, sand or water or air. So I'm not going to tell you the answer. You need to predict first. Do you think that sand would have the highest density, or water would have a higher density, or air would have a higher density? So you can either accept your hypothesis, that means if your prediction is correct, and if your prediction is not correct, then you reject your hypothesis. So when we conduct a hypothesis, you need to identify variables. So now the most important thing in a hypothesis is to identify variables. And I'm going to explain what variables means. So before I explain what the variables means, you need to ask yourself these questions, because now I'm teaching you how to become a researcher. So you're going to ask, which variables must be kept constant to make the test fair? So now in every hypothesis, we need to have a constant variable to make sure that the test is fair. If we don't have a constant variable, that means that the test is not going to be fair. Okay, so we're going to go back to the lesson. This is just a little technical glitch. Okay, so another question for you to ask is, what is the independent variable? So that means, why do we have control over it, over the investigation, and what are the dependent variables? So the most important thing for you to know is, what is the independent variable and what is the dependent variable? So a dependent variable is a variable whose value depends on another variable. That means that what is being studied and measured in the experiment, it also is what changes as a result of the independent variable. So the most important thing you need to know about a dependent variable is what changes as a result of the independent variable. So which variables must be kept constant to make the test fair? So it would be the volume is a constant variable. So the cups that you're going to use, it must be all of the same material, it must be of the same size, so that it would have the same mass. So the constant variable is the volume that you're going to use, the cup that you're going to use to measure your sand, water, and air. Right, and then the independent variables is basically, what is the independent variable? That means, what is it that you have to control to change the investigation? So what you're going to control in investigation is the type of the material. Like for example, the air, the water or the sand, or even if you're going to use the flour. And the next question is, what are the dependent variables? That means the independent variable is the type of the material, my apologies, sorry, which is the cup that you're going to use. So the cup that you're going to use is fixed and it's constant. So that's the independent variable. And then the dependent variable is basically the mass of what you are going to calculate. So mass is measured and it is used to calculate the density. So the dependent variable would be the mass that you are going to measure of the three components, which is the sand, the water, and your either flour or, sorry, not air, tap water or your water. So what you need to write down is this. You need to conduct your experiment. You'll need to have identical cups. You can either use plastic cups or paper cups. Then you'll need some amount of sand. You can get this from your garden outside. Or if you don't have sand, you can use flour. Then you can use tap water. And then you'll need a scale. A scale too. If you don't have a triple beam balance scale, you can just use your ordinary bathroom scale. So you're going to put a certain amount of sand in the cup, and then you're going to measure it. Then you're going to put flour in the cup, and you're going to measure it. Then you're going to put water in the cup, and then you're going to measure it. So you can, I'm going to teach you the method. Now, when you're going to do your experiment, you're going to design this investigation by yourself, or you can work with someone at home. You can work with either your brother or your sister or your mom or your dad. Now, when you're going to set out the investigation, you're going to first ask you to have a discussion. How are you going to carry out? Now, carry out, another word for carry out is conduct. How are you going to conduct this investigation? So you have to do some sort of planning. So you're going to write down your different methods in a notebook, or you can keep some scrap paper. And you can discuss with your partner, your sibling, or your parent the different ways that you're going to conduct it. Now remember that you need to record your results. And now in every investigation, you have to record your results, and then you write this down. And when you finish recording, you must summarize your findings. So this activity will help you to develop your skills, and it would prepare you for higher grades. So now what you're going to do is you're going to measure the mass of each cup to show your calculations of density of each material. So you're going to use your formula. Density is equal to mass over volume. So you can say D is equal to mv. And you must remember to, when you finish writing it, you must write the units of measurement. So if you use grams per milliliters. So now you must do an analysis. Your analysis and evaluate means that you need to reflect and evaluate. When you reflect and evaluate, you need to ask yourself, did anything go wrong during the experiment? And then you must record. That means you must write down if anything went wrong and what went wrong. If nothing went wrong, then you also say that the experiment went well. Then can you think of anything that could have improved the experiment? So what could have made the experiment better? So this allows you to think reflectively, and it improves your skills. Okay, so the next time you want to do something, you'll remember these things. And then what steps did you ensure to do fair testing? So like you use the same size of cup and the same material. So now I want to do, we have about 3 or 4 minutes left, so I want to teach you how to do some density calculations. So we have the density of liquid, ice, a gas marble, salt, chalk, coal, and cork. So this is the density of each of it. Now I actually wanted you to do this. So if you had to have 500 grams block of butter at home, and if you knew that the mass is 500 grams, and it has a volume of 555 milliliters. Then you're going to ask yourself, what is the density of the butter? So you can think about what formula are you going to use. You can write it down quickly. Use the short form. Okay, so your formula is basically D is equal to M over V. You put your 500 grams here. You put your volume here, 550 millimeters. You use your calculator and you get this answer of 0.09 grams per milliliters. Now, when you're going to do your experiment, this is how you are going to record your findings. But you will probably put flour, and then you'll record your findings. Then you'll probably put sand, and then you'll do your density calculations. And then you'll put water, and then you'll do your density calculations. Okay, and then I want to ask you, oh, sorry, I already put the answer, but if you looked at the table here, which substance material is more dense? Is it the salt or the chalk? So we look at the calculations of the chalk, and then we look at the density calculation of the salt, and we see that the chalk is higher, so that is more dense. And then you have a large glass marble. So here is glass marble, and you want to find out what the volume is that you measured to find. And if you say that it has a mass of 50 grams, so what is the volume? So you say density is equal of the glass. You take it down from the table, then you're given your mass, but you don't know what the volume is. But what you do know is this formula of the density. Sorry about scribbling there. So the formula of the density is D is equal to M over V. So what we do is, in math you learned, you take this V and you carry it over your equation sign. I normally like to call it the bridge. So it becomes D times V is equal to mass. So now we have to convert, but we don't want to find the mass because we have the mass. We want to find the volume. So what we do is we take this volume here, and this density here, and we put it at the bottom underneath the mass. So we say V is equal to M over D. We put our calculations of 50 and 2,6, and we find our volume, and we must put our units of measurements. If you don't put the units of measurements, you lose marks in the exam. So I have this that I was going to prepare for you, where I wanted you to calculate the density of different things, but I'll put it in tomorrow's lesson. I want to do question and answer time. Does anybody want me to go through any slide? You can write it on the chat, and then my host will post it to me, and I can answer your questions. If you need me to go back to any slide, if you don't want me to, then it's fine. I can continue with my lesson. Okay, I'll continue because I did go very slowly, so I think you all understood. So what we have, my host will let me know if you have any questions. If you have a piece of coal and a piece of cork that are exactly the same size, we have the same volume, okay? So we have a volume of 100 millimeters. Now, which one will have a greater mass? And you can calculate the exact mass of each piece. So we have here, we know that the density of the coal from the previous slide was 1,5 milligrams. And now we wanted to find out what the density of coal, the mass of coal is. So we use our formula. D is equal to M over V. Then we're going to use some mathematical skills, and we're going to find out how we're going to take our volume here and carry it over on the other side of the equation. and we say density times volume is equal to mass, and we can rewrite it in this way because it means the same thing. So mass is equal to density. The density is 1,5, and we got this from our table. And 100, the volume is 100 millimeters, and we got this from the question that they gave us here on top. So if we multiply it, it gives us 150 grams. And then if we're going to calculate the density of the cork. Now, I also want you to see how I set it out. I set it out in a specific way. I wrote here what was given to me on the table. Here, I wrote out what I wanted to find. Then I wrote out here the formula, and then here I did the conversion of the formula. And only after I got my information, did I begin to do the calculations. So it's very important to train your mind. So when you're training your mind means that you're going to think like an investigator. Okay, so what do I have? What do I need to find? What is the formula? How can I change the formula to find out certain the things that I need? So I showed you how to change the formula. So now we're going to do the same for the density of cork. So we know that from the table above in the previous slide, we had the density of cork. We're going to find the mass of the cork. So we apply our formula. D is equal to M over V. Then we take our V on the side again. So it becomes D times V is equal to mass. We rearrange it. So mass is equal to density times volume. We put our density and we put our volume, and we get what our mass is. And don't forget to write the unit of measurements, because in exams, even you may write the answer and your answer is correct, and if you don't write the unit of measurement, they will subtract marks and you lose marks for no reason. So even in exams, don't rush. Take your time and do it, so you don't forget to do whatever you need to do. So when we get our answer and we see the coal is 150 grams, and then the mass for the cork is 25 grams, we come to our conclusion. And our conclusion is the coal has a greater mass as it has a higher density. So our conclusion is that the mass for the coal is greater, and you can see that the density for the coal is greater than the density of the cork. Okay, I hope that makes it clear for you as well how mass is related to density. We did this through this calculation. So we saw the higher the mass, the greater the density. So the mass here for the cork was less, so the density was less. Right, so what I wanted you to learn from this lesson was that materials with loose textures like bread or sponge or my host said that he published 3 questions, but I actually didn't see them. So I think because we're getting used to this new Teams, we have a little technical glitch. So if my host can republish the 3 questions, then I will go through it. But if I can't see it, then he will tell me what the questions were later on, and I will go through those questions tomorrow. So don't feel that you didn't get a chance to see get a chance to answer the questions. My host does know what it is, and if I still don't see it in a few seconds, that means that I will answer those questions for you tomorrow. Okay. So until I see the questions, I'm just going to go through this. So we say materials with a loose texture has empty spaces or holes inside them, which means that it has less mass in relation to their volume. Right, and this materials tends to be less dense. So what you need to know is Empty spaces means that they has less mass in relation to their volume, so it is less dense. And the materials that are less dense always float on materials that are more dense. So we say materials that are less dense. Remember where we went through the oil and the water experiment? So less dense materials float on um, more dense materials like oil floating on water. So I'd like you to, all the information that I derived from this presentation is from the Siyavula books on the internet, which is also very similar to the Department of Education's books. So what you can do is you can actually take down this YouTube address here for ice and water. So ice water and heavy water. So this YouTube address has a nice way of visually learning how in our previous experiments where we did why ice flows on water. And this is a really cool video to watch where you had a density tower, which means the three substances in a cylinder. And it's a really cool video for you to watch that explains density going through the 9 layers. So you can take down that address as well. Our next lesson is on expansion and contraction of materials. So before and I will answer the 3 questions that we have. You are welcome to contact me on ahaffea@gmail.com. That's my email address if you want slides of this. Also, this video, this lesson would be put up on YouTube. You can download it so you can learn through it slowly. Okay, so this is, okay. So now it says that my PowerPoint is not responding, but that means that my lesson has ended, which I've covered all the material that I needed to. So thank you so much for attending, and I will see you tomorrow.